So last essential standard, we learned about a lot of different quadrilaterals. Now we're going to do the perimeter and area of those quadrilaterals. So how long, oh wait, have you guys ever played with tanagrams? You know what those are? They're like anagrams. They're like those little square puzzles. And there's like triangles and squares and parallelograms, and you can rearrange them to like look like a dog or a horse or a thing. Or some of you guys. Basically, what that's doing is using the area addition postulate. So it's taking that area of a square, it's cutting it up into different shapes, and then it's moving it around. Does the area ever change of those shapes? Nope. And you can still add up all the individual areas and find the area of that square or that buddy or whatever you just made with that. How long have you guys known the area of a rectangle?
Always.
Like since third or fourth or forever. Okay, so our goal with our quadrilaterals is to make them into rectangles so we can know what the formulas are. So our parallelogram, one of our new vocab words, was a height. Our height has to be perpendicular, so it has to make this 90-degree angle with our base. Okay, so to find the area of a parallelogram, we're just going to chop it off right at that height, and we're going to slide it over. Now, what shape is it? It's a rectangle. So now, how would I find the area of a parallelogram?
What's the area of a rectangle? Base times height.
How would I find that area of a parallelogram?
Base times height.
Base times height.
Sometimes you'll see that h referred to as the altitude. The height is the altitude. They're perpendicular.
So let's find the area of this parallelogram. That's super smushed and standard. Okay. So how do I find the area of a parallelogram? It's times height. But we don't know the height. The height is this dotted line right there. So how can I find the height so I can find the area later? Good old Pythagorean theorem. What's our hypotenuse? 34. 34, because opposite sides of the parallelogram are congruent. Okay, so Vincent, set up the Pythagorean theorem for me. To find h. What's our... Okay, so with these numbers, what is it? So here's our right triangle. It's kind of upside down from what we're used to. What's our hypotenuse?
34.
So 30 squared plus h squared is equal to 34
Squared.
Okay. Teach, what is 30 squared? Oh. Well, what's 3 squared? 9. And then it's just add. And then we keep our h squared because we still don't know that. And someone use your calculator. What's 34 squared? Tatum. We're going to use a subtraction po to get 900 over to the other side. So we get h by itself. We still have h squared is equal to 256. How do I get rid of a square? Square root. I take the square root. Put that in your calculator. What's the square root of 256? 16. 16 is a nice pretty number. Oh. What if it wasn't a nice pretty number? What if it was like the square root of 17? You just leave it. So that way we can get the most precise area that we can get. Yep, don't worry about dates to prom. Okay, so now we can find the area. So we are looking for area. What's our base? Be really careful.
On that?
On our parallelogram. 11. Okay,
Is the base just whatever is more horizontal?
Yep.
On parallelogram, the second trapezoid is 30.
So be careful. It's not this 30 up here. This 30 is just something we found to find our height. So it's 11. And our height we found was 16. What's 11 times 16? 176. What's my label? Units.
Minutes.
Millimeters. I found area
Squared.
squared.
Volume.
Alright, so this time we're looking for a base, and we know the area and the height. So I'm still gonna write the same formula, so area equals base times height. Veronica, give me one of the numbers that we know. 56, where does it 56 go? Yep, so we're looking for a base times the height of 56, and that leaves our area at 28.
So we actually know the answer this time. We know the area is 28.
How do I get b by itself?
Divide.
Subtract.
It's
being
multiplied,
so
so
we're going to divide. We gotta do that.
inverse operations to divide, undo.
So what does b equal? 1/2. And what's my unit? Yards. Be really careful. This time we're looking for a length, so it's just yards. It is not yards squared.
The aircraft.
Next up is triangles and trapezoids. So how long have you known the area of a triangle? Forever. Like maybe a little later than a rectangle, but still for a while. You can have that on your paper, but I'm also gonna write it as base times height divided by 2. Isn't multiplying by 1/2 and dividing by 2 the same thing?
Yes.
They're mathematically equal. Okay? And then I want you to look at the area of a trapezoid. That formula. You remember last unit when Mr. Starks was like, triangles and trapezoids are have a lot in common, right? Because it's just chopped in half. What's the only difference with our formulas?
There's 2 bases.
There's another base for a trapezoid. Okay? So, again, our goal is to turn things into stuff we already know. We already know a rectangle. And from there we do a parallelogram. So for our trapezoid, they're just kind of swinging it over. So they're doubling it. Kind of like that tanagram, they're rotating it and making it into a parallelogram. And from there, you can chop it off and move it over to make it into a rectangle. So let's find the area of this triangle. What's our area of the triangle formula?
Base times height divided by 2.
Base times height divided by 2. Do we know the base? Oh no. What are we gonna do? We're gonna use the Pythagorean theorem. Ryan's so excited. Who wants to set up the Pythagorean theorem? Lexi does.
12 squared plus b squared equals 20 squared.
Chloe, what's 12 squared? 44. We keep our b squared. Parker, what's 20 squared? 400. And you use a subtraction code to get 144. Subtract it from both sides. 256. And then take the square root of it. That's one we did in 2 examples ago. So it's the square root of 256. And now we can easily put that into our area formula. We have area equals the base of 16 times the height of 12 and divide it by 2.
Did I call 12 the base? Yeah, if 12 is the base, what's the height? Yeah, the side that's perpendicular. So it doesn't matter what's what, just know it's perpendicular.
96 what? Meters
Squared.
squared. We're finding area. So area is always going to be the unit squared. So in this example, we're given all the information we need to find the area. Colin C, one thing I know. So we have height is 6.2. Colin S, what's something else I know?
The first base is 8.
First base is 8. Ryan, something else?
The second base is
5. And divide it by 2. Now you could do these in like individual steps, but I would like highly recommend just putting it in your calculator exactly how it looks. So that way there's no room for error. Okay, so how do I get a nice pretty fraction with the 2 boxes? You guys remember? Alpha y equals, it's that first one. I'm going to type it in exactly. Not even going to do 8 plus 5, because sometimes, when you're testing, you forget what 8 plus 5 is. Times 6.2 divided by 2. You should have gotten 40.3 what?
Alpha squared. Alpha what?
Inches squared. Alpha y equals, and then hit enter. So what was the answer? 40.3 inches squared.
That's not the area.
That was the area.
Oh.
This time, we're looking for a base. Okay. So, same formula. Area equals, add up the bases. Multiply it by the height and divide by 2. So we're given area. Plug that in. Given one base. Looking for the other one. And our height is over here as well. And Lynn, how do I get rid of that 2 on the bottom? Multiply both sides. So when I multiply this side by 2, those cancel. Multiply by 2, they should get 462 is equal to 23 plus the second base multiplied by 11. Rachel, how do I get rid of the 11? Yep, we got to do the opposite. So it's multiplied, so we're going to divide. So it's 462 divided by 11. Hold on. Said 42 is equal to 23 plus the second base. Yep, and then just subtract 23. So what's our second base? 19 what?
Millimeters.
Yeah.
Meters.
Just millimeters. We're looking for a length. So find B. That's just one length right there. So it's not squared. We're looking just for like how many. If I took a ruler out, I would be able to measure it if it was on this very blurry picture. What was our area of the kite or rhombus? Go back. So 1/2 times one diagonal times the other diagonal. So 1/2 was our first diagonal. 11. What's our second diagonal? 8. And 44. You get 44 what?
Centimeters squared.
Squared. Why is it squared?
Area.
Because it's the area. Find centimeters. Let's find the diagonal of a kite.
Find it.
Let's find it. So we have area equals 1/2 diagonal 1 diagonal 2. So Ryan, what do I know in this equation?
The total area is 238 inches squared.
Veronica, what else do I know? 14 is one of my diagonals, and I'm looking for the other one. So what's our...
I will be here next time.
Who's going to Dawn? Nope. What? Dawn.
No.
so much for your